So this is the trailing edge. Remember, in a steady flow, if you have a constant gamma naught here, in two-dimensional, there is no shed vorticity. That's it. There's no wake. This is why we're emphasizing, if you have an unsteady, if this guy changes, then it must shed wake. Okay? And he simply said the amount of change here, if this guy is going to decrease by a little bit, this reduction in the circulation will go here. Or if it increases a little bit, this. So if this guy reduces a little bit, the amount of circulation here will increase by this exact same bit, and vice versa. So gamma naught dot dt. This is the change in gamma over the airfoil, right? This is exactly equal to the change in wake circulation, right? In negative. Correct? And the change in wake circulation we have it distributed. So we have gamma wake at B, right? Time t, because it's here, times dz. So the infinitesimal amount of circulation in the wake at this time is just exactly equal to the change of down circulation. Do you agree with this statement? This is actually this is so the conservation of circulation. Let's look at this for a minute, please. When you have a circulation, okay, or vorticity, it diffuses because of viscosity. Diffuses. So you know, it's as if you have a heat here. This is very hot plate. The heat will diffuse. Okay. But this diffusion needs some time. Takes time. Okay. The same vorticity diffuses by viscosity. So if you ignore viscosity, you have no diffusion, so you have constant vorticity. This is the conservation of circulation. But this does not require implicit. Even if you have diffusion instantaneously, this is correct. Because as this is applied instantaneously, it does not apply over a long period. Do you see what I'm saying? So even if you have viscosity, so this is important. So anyway, the fact that everything is proportional to EI omega t makes things very easy. So this guy is gamma naught dot. Again, like everything, gamma naught is gamma naught bar EI omega t. So if you need a gamma naught dot, it's gamma naught bar EI times times EI omega t, right? And actually you'll divide by dt here. dz by dt is what? What's dz by dt? U. Very good. And this guy is gamma wake bar at B EI omega t. That's right. But we know that gamma wake of Z and T is gamma wake again of B. Or actually, let's do it here. So yeah, sorry about that. So we can do it here. We can do it here, just before leaving. So this is equal to this guy, gamma wake at B and time t. It will be gamma wake at Z, but later in time. T plus, right? The travel distance divided by U, which is Z minus B. dz. So like I said, this is I omega, gamma naught bar. Everything this time is EI omega t, so I'll just ignore it, or you divide by it. And dz divided by dt, the other way is U. Here is the negative. This guy is gamma wake Z EI omega. Here is EI omega t. Just EI omega times all this guy. This is your time. So T plus Z minus B over U. So So you can divide now by EI omega t, and get gamma wake in terms of gamma naught. This equation is, I don't wanna, yeah, because I already went over time. I just want to do this. Yeah, here it is. So it's the negative I omega over u, as you can see, and we have E negative EI k. Remember, k is omega b over u, right? E negative I omega z over u. So we establish the relation between the weight and bound. Okay? So the immediate step is to, the next step is to take this guy, substitute it over there to get an equation in one unknown. We'll continue next time.